Okay, so we're going to do a program that actually does something now. And for a choice of problem, I just went to Project Euler and selected problem number 1. Those of you who took the class with me last semester know all about Project Euler. It is a database of problems, of exercises, of puzzles in mathematics designed specifically to be solved by writing a computer program. So there is, if I switch to the tab, will you guys be able to see it? Yeah. So these are the archives of projecteuler.net. You can go there and sign up for an account yourself, and you can see all the problems. They start easy. 100 and was that a million? A million people have solved problem number 1. Only 800,000 have solved problem number 2. And as you go further and further down, you will find that fewer and fewer people have solved them because they get harder and harder and harder. You get up to problem 800, only 200 people have solved it. Problem 880, only 112 people have solved it. I've solved about 50 of them myself. I was in a race with one of my kids for a while, and they had solved, I think, 48 at the start of last semester, and during the Python class, I passed them, which was fun for me. But they start out really, really easy. Here is problem number 1. It says, can you read that? It's maybe too small. If we list all the numbers below 10 that are multiples of 3 or 5, they are 3, 5, 6, and 9. And if we add all those numbers up, we get 23. So the problem is, for all the numbers below 1,000, add up all the multiples of 3 or 5. So any number divisible by 3, any number divisible by 5. Pretty easy problem. We're going to start with just our basic skeleton of a Java program, and I have here in the comments what we will learn in the process of doing this. We'll learn how to create an integer variable. We'll learn how to use the modulo operator. We'll learn just really, really basic logic, how to do an if statement, and how to do a for loop in Java, because obviously we're going to have to count through all the numbers from 0 to 1,000. So it's a pretty simple problem. I'm not going to pseudocode this out. If you want to take a minute to pause the video, and actually eventually I'm going to put in a little pause screen so that you guys can click pause and think about the algorithm yourself. But basically we're going to count up from 1. We can actually start at 3 since we are only interested in multiples of 3. Count all the way up to 1,000. Check every number. If it's divisible by 3 or divisible by 5, we add it to some running total, some total sum, because that's what we're interested in. We're interested in adding them all up. So we'll need 2 variables, I think. We'll need the number that we're counting up, and I'm just going to call that, I don't know, what am I going to call that? Number. Give me 1 second here. I just want to make sure I use the same variables that I used in the sample code for you guys. So I'll just call it number. So I'm going to create an integer variable called number. I'm not going to give it a value yet. This is, in Java, something that is different from Python. In Python, we could just create a variable and give it a value. And Python would figure out if the value I gave it was an integer, that variable is an integer. If the variable is given a value of a string, then that type of that variable is a string type variable. If I give it a decimal, then that type of variable is a floating point decimal. Java doesn't let you do that. Java does not figure out what kind of variable something is based on what you put in it. You have to tell Java, this variable I'm creating is an integer or a string or a boolean or a float. So when I write this statement, it creates a variable called number of type int. We'll talk about the limitations of the int variable type, the data type, a little bit later. That is called declaring the variable. So I've declared the variable number. And I'll create another variable called sum. And this time I'm going to give it a value. Okay. That's called initializing the variable. If you create a variable and give it an initial value, we're going to create a sum that we're going to add to every time we find a multiple of 3 or multiple of 5. Okay? Now what we need is some kind of loop that counts from 1 to 1,000. That's the maximum number that we're told in the Project Euler problem that we need to go to. We talked about this a lot last semester. If you know how far that you've got to go in a loop, the tool for the job is a for loop. A for loop says take some variable and count up to some maximum and then stop. So since we know that we only have to go up to 1,000, we're going to use a for loop as our structure here. And this is the syntax for that. It's for, and then a parentheses with 3 statements. 1 is where you start. So we start at number equals 1. 2, the stop condition. And the stop condition is we keep going until the number's not less than 1,000. Maybe we should say that better. The condition that you keep repeating is that you repeat it as long as the number is less than 1,000. And then the increment that you are doing every time through the loop. And the default, most of the time when you're going through a loop, you're going up by 1. So this number plus plus is a shorthand for just saying the number goes up 1 every time you go through the loop. So that is the syntax for a for loop. It's always going to be the same in Java. And then we're going to put a open and close curly bracket here to put the contents of our for loop. So that open and close curly bracket contain the commands that will be executed as part of this for loop. So I'm counting up from 1 to 1,000. And notice it's less than, not less than or equal to. The problem specifies below 1,000, not less than or equal to 1,000. So that's important. What am I going to do? I'm going to look at every number and say, is it divisible by 3? Is it divisible by 5? If either one of those is true, then add that number to the total. What does it mean to check if something is divisible? For that, we use the modulo operator. I think you'll find as we go through this first week or so, or week or two of content, that the mathematical operators in Java will be familiar to you if you've taken any programming course at all. So we're going to have an if statement, same as Python. And if my number that I'm counting up is divisible by 3, okay, so if number modulo 3 is equal to 0, I don't need, let's put that parentheses here. I want parentheses between my two statements. If that's true, or if number modulo 5 is equal to 0. Remember, the double equals means is equal to, whereas a single equals is an assignment. It says take this value and put it into this variable. A double equals is a question. Are these two things equal? And I need an or in here. In Python, we would just write the word or. It's not so simple in Java. The Java operator for a logical or is 2 vertical lines. The vertical lines that are over top of the slash, usually over top of the return, 2 north of the return button on your keyboard. So this, let's put a comment in here. The operator is or in Java. By the way, let's scroll up here a little bit. We're not using it. Extra period in there just from a finger slip. But since we're going to need it soon, I'll go ahead and put in here the operator ampersand ampersand is and in Java. Okay, so the and or operators look like this. So this statement says if number modulo 3 is 0, it's divisible by 3, or number modulo 5 is equal to 0, then you do something. What do? We take that number and we add it to the sum. So we can put down here the curly brackets that go with this if statement. What are we going to do? We're going to add that number to the sum. So sum is equal to whatever it was before plus number. Okay? This is the end of our if. This, I put a bunch of returns in here to just to help keep it all in the screen. This is the end of our for. Most programmers wouldn't do this in their code, comment the end of every single curly brace, but I just do it for you guys to help you follow the code. Sometimes I do it for me when my code gets really complicated and things get kind of messy. Okay? So now all we need to do is report the result. So let's go ahead and after the for loop, after it's done all of that, we'll have some output statement. System out print the sum is, and then system out print line, which goes to a new line, the sum, the value of the sum when it gets to the end. Okay? Let's run this and see how many semicolons I've missed. I missed that one. I think that's the only one. We'll see if it compiles without an error. There you go. It runs, and it gives me a number. Probably good to, at the beginning of the program, have a statement so I know that something is happening. This program adds up all the multiples of 3 and 5 less than 1,000! Exclamation point. Close. Just to tell the user what the program does. I don't know why there's an extra semicolon in there. I think I accidentally wrote over something. System out print. Quote, parentheses, semicolon. Okay, and we'll probably put a couple line feeds in here to make things look pretty. There we go. So the program tells the user what it's going to do. It does its calculation. It prints the result. How do we know the result is right? Well, we can copy that number 233168, and we can go to Project Euler, and it has a little box for you to type in your answer, 233168, and we'll see if we're right. Yay. I love the big happy green check mark. It's one of my favorite things, especially when I've spent days and days and days working in on a problem and getting the wrong answer. It's very satisfying to get the green check mark. If you like, and now when we go to our progress, it'll show number 1 colored in because we solved it. If we go to the archives, it'll be a little check mark next to the 1. And once you solve a Project Euler problem, you can click on the chat forum and you can go see other people's examples of how they solved that problem in all sorts of other languages. This person did it using R. This person did it using Nim, which I've never even heard of. Here's someone who did it in Python and maybe in Portuguese or Spanish. So you can see other people's code, sometimes much more compact. Notice that this person's code is not commented at all. I would give them a B- for that code, for not putting in any comments. So the homework that I have for you as a follow-up to this is to do this problem in a more general way. In other words, instead of finding all the multiples of 3 and 5 below 1,000, ask the user for a number and 2 factors, and then find all the multiples of those 2 factors less than that number. So a more general version of this problem that will work for any 3 numbers, not just 3, 5, and 1,000. So that's the homework that's due based on this problem. I'll put a link to this code right next to the video, and in our next couple of videos, we will look at all the other mathematical operators, multiplication and division and whatnot. And we'll look at factoring and finding prime numbers and basically all the stuff that we did in 221 in Python, and kind of just doing it over again in Java, because I think that these simple problems and simple activities are an easy way. We've already thought about the algorithm ones before. They're fairly easy algorithms. It's just a good way to get our feet wet with the Java syntax, and that's all we're doing in this first couple of weeks.